Okay, so let's talk about site plans, and we're going to learn how to draw site plans today. And we're going to also learn, or not learn, but we're going to talk about how to print your site plans. We're going to talk about how to scale your site plans. We're going to talk about the different layers that your site plan lines need to be drawn on, okay? And I'm hoping to get through the basic site plan today and potentially introduce the idea of an advanced site plan. But if I don't, then we'll just get to that on Monday, okay? So we have a few civil engineers in here. They will use this skill for sure. You'll be drawing site plans in your profession, right? But in architecture, you definitely use a site plan. You may draw what's called an architectural site plan, but you will in commercial projects for sure, and residential projects, well, I'm going to say for sure in residential projects now because the cities are now requiring it. But you will manipulate and use site plans definitely for your designs, okay? And then all of you other engineers, mining engineers, what other type of engineers do we have in here? Anybody I haven't mentioned? Don't be shy. Okay. Most type of engineers will use a site plan. The only one I would say maybe not would be a mechanical engineer, which is, nuts and bolts kind of manufacturing. Okay, so that would likely be the only type of engineer slash product designer that wouldn't use these. Okay. So the first thing I want to talk about with regards to drawing site plan, I want to talk about the units we're going to draw them in. So we're going to introduce a third type of unit that is available in AutoCAD, and that is surveyor units, okay? So we have, if I come down here in my AutoCAD interface, and I just opened up a blank document. We're going to be working with a blank document today. But if I just click on architectural, you see we have decimal, engineering, fractional, scientific. I don't have surveyor units down here, okay? But I am going to change to decimal. All right, so I'm changing to decimal here. And then I need to set my units to surveyor units, okay? So I'm going to type in units actually. I'm going to type in units at the command line and hit enter. All right. I also, to find the units, I could have also gone to the application menu and gone to, let's see, drawing utilities and come up here to units, okay? All right. So let's talk about our units here, okay? Surveyor units are sort of a format within the decimal type actual units, okay? So decimal, our precision right here, this is a pretty good precision. We have 1, 2, 3, 4 decimal points here, okay? We may have to change that in a second, but we'll leave it like that for now. Surveyor units are a type of angle within decimal units. So to set our decimal to recognize surveyor units, we're going to click down here and we're going to choose surveyor units. Okay. Now we have a precision in surveyor units, and let me explain the idea of precision. Okay. So if you, for example, don't change anything if you've changed your interface, but if, for example, we're in architectural units and we have a precision set to 1/16 of an inch, okay? If I draw a line that is 1/32 of an inch in length, AutoCAD will round it up to a 16th if my precision is set to a 16th, okay? So the precision essentially tells you how big or how small you can draw to in AutoCAD. Not to say that AutoCAD isn't capable of drawing extremely small increments, because it is. We can draw, 1/256. That's pretty small increment, right? So we can draw these really small increments, but if our units are not set to recognize that, then AutoCAD will round things up, okay? So I think likely, depending on what you're doing, a 32nd of an inch precision for architectural is pretty, that works out pretty well, okay? So under decimal, okay, this precision looks pretty good. I can't explain to you the terminology used to identify the precision in surveyor units, but I know that I need more precision than is illustrated right there. I know that I need this precision. It's the third one down, and it shows degrees, minutes, seconds, and then direction, okay? So we want to see a direction, we want to see that 0 degree, 0, 0, which is minutes, 0, 0 seconds, and then another direction. Okay, that's the precision we want to see. I wish I could sort of zoom in on this, but it won't really let me. All right, so I'm going to hit OK now. And that is really the first step in drawing a site plan, setting my units. Okay. The next thing that I'm going to do is I'm going to create some layers to put my site plan lines on, the property lines. Okay. So what layers do we need to create? Well, let's go over that. I am going to pull up our AutoCAD menu or manual here. This is from the manual from last time. Okay. So AIA CAD layer names. Okay. I'm going to explain two different things for you here. All right. So we have our architectural layers, which we talked about. Right? If there's an A or an AE in front of a layer, that means the architect is responsible for those layers. We have C, which are civil layers. So if there's a C in front of a layer, it's the civil engineer's responsibility. We have E, which is electrical, same, system applies. F for fire protection, I for interior design, landscaping is L, and mechanical is M. There's plumbing. Plumbing is P, telecom is T, and structural is S. Okay. So what we want to do here is we want to create a property boundary line. Okay. So I'm going to go over here thinking C for civil, and I'm going to come down here and look for property. Oh, there it is. Property lines, survey benchmarks. So the layer that I'm going to generate is called C-prop. All right. If you're a civil engineer and you're working in a civil engineering firm, C-prop is the correct layer name. If you're working in an architectural firm, you're likely going to create an architectural boundary, so you probably will have an A in front of your layer. So A-prop or A-prop-ESMT easement or whatever, okay? But for our cases today, or for our purposes today, we're just going to use the C-prop for one of our layers, okay? So I'm going to come up here to layer properties. I'm going to add a new layer. I'm going to call it C-prop, enter. And actually in our booklet here, let me just find it. The in-class exercise we're going to do talks about what color that line needs to be. There we go. Okay, so here we go. So we're going to create our AIA layer names. So we're going to create C-property line, and we're going to use a border line type for our property lines. Okay. So right now what that means is C-property, the line type is continuous. We don't want it continuous. We want it called border. So I'm going to click on continuous, and I'm going to hit load, and I'm going to find border. Oh, there it is, border, and I'm going to hit OK. Make sure it's selected and hit OK. And the final thing I'm going to do is give it a color, which then translates into a pen weight, right? A thickness of line. And it doesn't show that in the in-class exercise here that I have in our manual that is going to be posted online. So I'm just going to tell you, let's use a red line type, okay? Red is pen number 1, and it's one of our thickest pen weights. So I'm going to click on white here, come down and choose pen number 1, which is red, and hit OK. C-prop, color red, border line type. Great. The second layer we're going to create one for setbacks, okay? And we can use, without me having to go back and look at my PDF, I'll just tell you. We're going to create a new layer, and it's going to be called C-prop. So it's a major category property lines, and this is ESMT, easement. Enter. Okay. I'm going to click on red, and I'm going to make this color 2 steps down from red, which is green, because I still want it to be a somewhat thick pen weight, but it needs to be less thick than the property line. Okay. I'm going to hit OK. And then the line type that we need is use a hidden line type for the setbacks. Okay. So I'm going to click on my, and you notice it says border because if you remember this, when I create a new layer, it assumes the properties or definition of the layer that I previously created, right? So this is a copy of the one that I just created, right? But I want this to not have that borderline type. So I'm going to click. I don't have hidden, so I'm going to hit load. And I'm going to come down to hidden. There's hidden, hit OK. Click on hidden, hit OK, and now I have my layers defined correctly, okay? We're really going to today only be using these two layers, so C property easement. Let's see if we can delete a few of these other ones that we have in here. You likely may or may not have these because I created these when I was illustrating things in class. So I'm going to click on layer 10, and I'm going to come up here to this little delete layer, and it did go away. That's good. Layer 9. Delete, layer 8, delete. Every now and again, you may create a new layer accidentally, and you go to delete it and it says, hey, there's something on that layer. And you think to yourself, I didn't put anything on that layer, right? And you go to that layer and you look at it and there's nothing on it. Anyway, sometimes that happens, just so you know. So every now and again, you get some layers that you just can't delete. Let's see if I feel like I'm having really good luck. Yeah, oh good. I was able to delete all the ones except the two that I wanted. Okay. I'm probably going to be drawing the property lines first, which is the outer boundary. So I'm going to click on my property line layer, and that made it current. Okay. I know it's current also because I can look up here, and without a command active, I see C property line as my current layer right there. Okay. All right. Any questions so far? All right. I'm going to save my file. This is probably really good practice. Just start saving your file in the beginning, of course, because you don't want to lose any of your work, right? So we'll call this, not property lines. We want to do site plan, save. Okay. So I've saved my drawing. I've opened it up. I've created some layers. I've changed my units to decimal. I've defined my decimal units to be drawn in surveyor units, okay? All right, so I want to show you how to draw a site plan in surveyor units, and then today I'm going to show you how you can then take that site plan that's in surveyor units and translate it to architectural units, okay? When you draw something in decimal units, essentially what that means in the real world is that you're drawing in decimal inches, okay? So what that means in terms of using an architect using a site plan, an architect has to take a site plan that is drawn by a civil engineer and scale it up by a factor of 12 to convert it from decimal inches to feet and inches, okay? So we're going to draw our site plan in surveyor units, and then we're going to scale it up by a factor of 12 so I can show you how an architect makes it useful for them. Okay. All right. Let me talk about surveyor units and show you the format that they are going to be drawn in. Okay. So we are going to draw. Let me show you also an image of what we're going to be drawing. And hint, hint, it's going to be very similar to your assignment. So if you draw it correctly in class, then you might have part of your assignment finished. Okay. This is what the site plan that we're going to draw is going to look like. Okay, so it's kind of a diamond shape thing, right? One thing I do want to describe too, let's zoom in here a little bit, okay? We have a point of beginning, POB, on our site plan. That's located at point 00. That's the origin in AutoCAD. So when we're creating site plans, this is likely one of the only type of drawing exercises where you actually worry about where the origin is in AutoCAD, okay? We have a surveyor unit bearing here, right? This is really the same thing as saying 15 feet at an angle of, 20 degrees, okay? But it's in surveyor units. We have another surveyor unit on this property boundary. We get up here, there's one right there. We have one over here. Of course, each of these lines is defined by that boundary, okay? Now, Each of these lines, you could use the actual line tool to generate, or you could use the polyline tool to generate, okay? I'm going to use the polyline tool to create this because I'm thinking ahead, and I'm thinking I have to then, once I'm done generating this outline of this property boundary, I then have to offset it 20 feet, right? And create this inner easement. And if I use a polyline and this entire site plan is one line, I can offset that in without having any cleanup necessary, okay? Because if I use the line tool to generate this and I offset it in, there will be pieces of line right here that we just don't know how to deal with yet, okay? We will probably next time we meet, we're gonna learn some more modification commands to help with that. But as of today, we don't really know how to deal with that, okay? So this is what it's going to look like. Here's the definition of our surveyor units that will define these lines. I'm going to use a polyline to generate these. This outer line is going to go on the C-prop layer. This inner line is going to go on the C-prop easement line. Okay. I'm going to show you what a surveyor unit looks like, and then we're going to talk a little bit about how we decide how to draw a property boundary with that surveyor unit. Okay. So a surveyor unit, and I actually one time had a student in this class that she worked at the county in the where they print out plats, land department or whatever, and so she was able to explain what a surveyor unit actually means, but I can't remember now. But essentially it really has to do with quadrants of land and direction of the quadrants, and all you civil engineers probably know what that means. But I just take it for what it is and I draw it, you know, the way they've shown me, okay? So we have, first of all, with a surveyor unit, if you are starting from a previous point, this is going to be a relative input, okay? And we're going to start at point 0, 0, which is the origin, which means that the next point that I generate will be relative to the origin. So I have to use the @ symbol in that, okay? So I have the @ symbol. I have 158.21, which is a dimension, okay? So that is a decimal unit dimension, but that is the length of that line in decimal inches. I have this little angle symbol, which indicates that I'm transitioning from the length of the line to what angle the line is going to be oriented, all right? So before I get into what this angle actually is, I want you to notice that this is a southeast direction, okay? So if I think of AutoCAD in terms of directions, up here is north, east, south, west, okay? And that's kind of, if you look at the view cube, we have north, east, south, and west, okay? So if I'm looking at this and it says it's moving in a southeastern direction, right? It's going to be moving kind of at this, how my mouse is moving, southeast, right? Southeast, okay? I have south 86 degrees, 43 minutes, and 0 seconds, right? So these are surveyor units. South 86 degrees, 43 minutes, 0 seconds east, okay? We hear that in latitude and longitude, right? So that's really what this is all about. And it doesn't sound right coming out of my mouth. I'm like, that's a foot mark, that's an inch mark. It's not minutes and seconds, but in this world it is, okay? All right, so let's talk about inputting that into AutoCAD, all right? My property layer is current, so I'm going to close out this layer dialog box and I'm going to start drawing. So I'm going to use the polyline command. I'm going to start at the origin 0, 0, and then I'm going to type in my surveyor units that I want to input, okay? And when I type them in at the command line, I'm going to type it in exactly like this, all right? I'm not going to leave anything out. Let me do this. Let me split my screen just a little bit here so that we can see our site plan. Where did it go? There it is. Okay. This little guy, get this going. There we go. Ooh, almost. Almost. Okay. I'm going to zoom in on my units here. Okay, so point of beginning is 0, 0. We know that. then we're going to type in this surveyor unit. Okay, so I'm in surveyor units in AutoCAD, everything looks good. So polyline PL, or hit this icon up here, polyline, and specify first start point. Well, that's going to be 0, 0 at the origin. Enter. And you'll notice, I can pan over immediately, and you see that my line type is immediately generating as I draw this, which is great. Okay. So the next thing I need to input is this surveyor unit to get my first line going, my second point, and I'm going to type in my @ symbol. So @ and I'm going to type in my 158.21. All right, 158.21. If I type in anything wrong, just shout out, because I do it all the time with these. At an angle of, and this is south, so S. I don't believe that it makes any difference if you use a lowercase or uppercase s, but I just like to copy it identically, so I use uppercase, right? S, 86, D for degree. I'm going to use a small lowercase d. 43 minutes, and that's the apostrophe, right? 0, the quotes, E. Okay, at 158.21, the angle, S, 86D, 43 minutes, 0 seconds east. Okay, and I hit enter. Okay, I'm going to zoom out a little bit. I'm going to pan over, zoom out, pan over, zoom out. Oh, shoot. Okay, what's happening here? You see my little pan? I'm getting that little symbol. That is essentially showing me that I'm being constrained. I'm being limited. Okay. Oh, I did get to the end point. This is always my good illustration of how to deal with a limit, but sometimes you'll get that, okay, where there is space over there, okay? But essentially what you need to do is hit escape and zoom extents, and then that will clear out that constraint of that limit that's happening on the one side, okay? But I was able to zoom out, right? There's I'm panning, holding the middle roller down, moving over, zooming out a little, panning back over to see my endpoint. And that looks good. I could have hit escape, I could have restarted my line, but I want to kind of keep it as a cohesive polyline, so I'm, if I can, I'm going to try and keep this line whole. But if I can't, I'll show you a way to rejoin them, okay? All right, my next surveyor unit is going to be, let's see, this line. So this one's going northeast. Let's come back over here to AutoCAD. I'm going to type at 180.31. Now here's a little trick, okay? Here's what messes most beginning AutoCAD students up when we're entering surveyor units, okay? It's a little tricky too. You see this little foot mark right there, right? We are currently drawing in decimal units. We're in the decimal format. And a lot of students look at this and say, but there's a foot mark right there. And if I enter the foot mark and I'm drawing in decimal degrees, right, AutoCAD won't recognize it. And that's a true statement, okay? This little foot mark needs to be left off of your input of surveyor units when you're drawing, okay? The reason it's put there is for architects who are manipulating it, okay? But when you're drawing these, you're going to leave that foot mark off. Don't put it in there, okay? It'll mess up your surveyor unit input. So 180.31 at an angle of north, 18, D for degrees, 50 minutes, 00 seconds east. All right, so I'd just like to go back through it to make sure that I don't forget anything. The hardest part about these is just making sure you get the correct number, right? 180 at 180.31 at an angle of north, 18 degrees, 50 minutes, 0 seconds east. Enter. Okay. I'm getting my limits happening again. It's constraining, likely because this is a pretty big shape. So I think I might have to hit escape to get my next input to be on my screen. So I have to hit escape, zoom extents, zoom out a little, and I have to restart my polyline. So I'm going to come up here to polyline, click, zoom into that endpoint, get my endpoint snap to engage, click, and I can continue on, okay? Now I'm going to find my third input here. All right. This one is, we'll just continue on, at 185.18 at an angle of north 23 degrees, 27 minutes, 40 seconds west. Okay, look at it again at 185.18, an angle of north 23 degrees, 27 minutes, 40 seconds west. Okay, enter. We're cruising along, right? This is moving a lot faster. Looks pretty good, right? Now, well, I'll say what I was just about to say in a second. Never mind. All right, we're turning the corner here. This one is southwest, right? So we know that we're coming up to here. This was northeast, which looks good. It's going northeast, right? Now this one needs to go southwest just a little bit. So southwest, yes, this is a southwestern direction, so we know the bearing is good, right? One thing I really want to point out when we're doing these things is we are copying the site plan, but you know, the difference between all of you guys and people who maybe just want to draft, right? You need to really just kind of think about what you're doing. I mean, even drafters, right? You just need to think about what you're doing, essentially. So think about, you know, what this bearing actually means. You may not know what all the parts are, but you know that this needs, it has a certain length, and that 205.00 is pretty close to the 185 that you just input, right? And it's moving in a southwestern direction, and you can look at that and say, oh yes, it is indeed moving in a southwestern direction, right? Think about what you're drawing, and I say that because, you know, pick up on potential mistakes that could be happening, okay? That's part of your job. Just making sure things make sense, that they're working correctly, that they are concise, and they're correct, really. So we're gonna create this line now. I'm going to type at 205.00. Don't put the foot mark in. Remember, that will mess everything up. At an angle of south 50 degrees, 23 minutes, 15 seconds west. Okay. All right. I look over it one more time. 205.00, an angle of south 50 degrees, 23 minutes, 15 seconds west. Enter. Looks pretty good. All right, here's the most tempting decision ever in AutoCAD, right? It's very tempting to say, hey, guess what? I only have one line left, and I know that if I come down here and I just hit the end point, that it will close it right up, but we are never going to do that, okay? We're never going to do that, because when you're working in the real world, there is always the potential that there could have been a mistake when you were given some information, right? You have a survey done, somebody gives it to you and says, here's the survey information. You are drawing out that survey information, right? And if you just come in here and you just close that up, you're not verifying that information was done correctly, okay? So whenever you have something that is as important as a property boundary, right, very literally affects every aspect of a project. If this is incorrect, your easements are off, how close to the property line your design can be is off, right? The whole building really depends on this kind of initial exploration, right? So make sure that all these lines are correct, okay? So it is tempting, I'm tempted to do it, but we're just gonna type in our surveyor unit. We're gonna type at 201.36 at an angle of south 4 degrees 24 minutes 48 seconds west. Okay, I'm gonna hit enter. Ooh, I did something wrong. Ooh, not good, right? So I'm gonna hit in the middle of my command. Let me talk about a few polyline options that we have. Polyline is an interesting little tool. I can, number one, have my lines all continuous, which is great. The other thing that is really great about a polyline is that if I make a mistake like this, I don't have to hit escape and hit delete. Do you notice we have some options down here? I have an undo option. So if I click undo, it just undoes that last mistake that I made. Okay, so I'm going to redo it. Let's see what I did wrong. I'm going to type at 201.36 at an angle of south, right, south 4 degrees, 24 minutes, 48 seconds east. I don't know what I did wrong, right? But I did something. And what's that? Oh, did I put west? That's what, okay. Easy mistake, right? So I'm going to hit escape. And we have our outline. Now, let me just say this. So this is one of your assignments. You're going to be doing this. This does actually have a teeny little mistake in it. A couple of them, but you can't really see it unless you zoom way far in here. There is a tiny little mistake, right? So these do cross over a little bit. There's one exercise you'll be doing where I think it doesn't quite meet, but it's so tiny that unless you zoom way far in, it's going to be fine. Now, with that said, we're in school, but if that actually happened in the real world, I would likely question it, right? Somebody would be getting an email and I would say, you know, the survey doesn't quite come to, it doesn't come to a point. Things aren't meeting up. Is something slightly off? That would be something I would question, okay? But it looks pretty good. I think we did a good job, okay? Now, we have one polyline here and we have a second polyline here, which is, you know, not terrible. But the idea of me using a polyline to generate this site plan was that I wanted one continuous piece so I could offset it, right? And I don't have that here. So before I do that offset, I'm going to show you how to join a polyline after the fact, okay? So I'm going to show you how to join a polyline after the fact. I'm then going to show you how to scale this site plan so that it's the right size in architectural units. I'm then going to offset my property line to get the easement, and then we're going to print it, okay? So I'm going to type a command. It's called pedit, P-E-D-I-T, and that is short for polyline edit, pedit, okay? I'm going to hit enter. It's going to ask me, hey, what polylines would you like to join? So pedit, select a polyline or multiple lines. Well, in this case, we have multiple lines, which is 2, because our polyline didn't become continuous. So I'm going to click on multiple. If I can click on it, you'll also know there's a blue, notice there's a blue letter, that M. If I wanted, you know, of course I'm a keyboard person, I could type M, enter, and get the same effect. So I could click on multiple or I could type M, enter. Now I'm just going to select all these lines because I want to join them all together. Okay. When I'm done selecting, I hit enter one time, right? This command isn't difficult, but you can very easily get lost in it because there's a lot of enters. You have to select an option within it, right? So select objects. Well, I'm done selecting, I hit enter. Pedit, enter an option. Well, what I want to do, I don't want to close it. I don't want to open it. I want to join it. So I could click on join, or I could type J, enter. But I'm going to click join, and it says enter a fuzz distance. We're just going to hit enter there. Okay, I'm going to hit enter one more time. But before I do that, I want you to notice that you see right above my command line, it says 2 segments were added to the polyline. Do you see that right there? So the fuzz distance is, it's a gap, sort of a gap tolerance, okay? The idea behind polylines is that you don't want gaps between lines or they won't join, okay? And what that means is that if a polyline is connected or lines are connected by endpoint, you won't have an issue joining them, okay? So I know that this worked. I'm going to hit enter again. I'm going to hit escape, and that's the end of my pedit. And now all of my lines are joined together, okay? I'm going to hit undo, and I'm going to do that again for you. P-E-D-I-T, enter. M for multiple, enter. Select everything, enter. I want to join. I would type J, but I'll just click on join. Enter, enter. You see here 2 segments were added to the polyline. Escape, and it's joined. Okay? Your command line, you may not have been paying a whole lot of attention to your command line. I want to show you an additional functionality of your command line that will help you. It is F2. Okay, F2 is a list function, and what that does is it will allow you to see a list of kind of your most recent commands. Okay, so sometimes if like I entered that surveyor unit wrong, maybe I enter it again, I'm like, gosh, did I enter it correctly? What's going on? I can browse back and I can look at what I had done wrong. Okay, so I can see what's happening. These are all of the commands I've done. These are escapes. This is a save. This is a polyline, right? You can see everything that you've done here. Units. And I'm just rolling my roller to find them, right? But I can look there and see what's gone on too, okay? I can hit escape and it goes away. F2, escape. It's what's called a list, all right? It's a list of commands that you've just done. You can also type, I think you can type li, enter, oh, it's changed a little bit. Li list, select an object, hit enter, and it will show you information about that object, okay? So li, enter, select an object, enter, and it will give you the properties of that object. So it will say, hey, here's the area of that object, here's the length of all the continuous lines, it starts here, goes to here, goes to here, goes to here, and ends here, okay? It tells you what layer it's on. This is really great if, you know, your client calls you and says, hey, can you tell me how many, you know, what is the area of my property, or what is the area of this room, or what is blah, 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 blah. You can do a list on that object, li, select, enter, say, oh, well, it's, you know, this many decimal inches, okay? The property boundary is 930, I'm assuming this is decimal inches again, right? But you can get a lot of information about your object, okay? So we know about surveyor units now, how they're a subset or a setting of decimal units. We know how to input them into AutoCAD. We know what layers to put those site plans on. We know how to take a polyline and edit it so that you can join lines back together that have been created separately. The next thing we're going to do here, we're going to take this site plan and we are going to scale it up, okay? So if you were a civil engineer, you could likely skip this step because you would just continue to work in decimal inches, right? But if you are an architect and you have been sent this site plan, you need to translate it into architectural units so you can use it, okay? So we are going to, we're going to change this. We're going to scale it up, okay? Let me just make sure I haven't forgotten anything else yet. Let's see. Okay. All right. Now, before we do this, before we actually scale it, I am going to offset my boundary to get my easement line, okay? So I'm going to use the offset command, which we talked about. This is the offset command. I also could type O, enter, and it's going to say specify a distance. I'm going to type 20, enter. That was on my site plan over here, if you guys don't remember, 20, okay? I'm going to pick my object to offset, click, move inward. See, if I moved out, it would offset out, but I want to move inward, click, escape. Now, you're thinking it's on the same layer, and it is, but I can change the layer of the inner easement, grab it, select it, use the drop down to change it to green. Let me undo that. Okay. Offset, 20, enter, click, click. There we go. Easy as that, right? Okay. Now I'm going to change the layer of that. Click, drop down, property easement. There we go. Okay. Do we have any questions so far? Anything unclear? Okay. All right. So now what we're going to do is we're going to scale this up by a factor of 12. Assignments, as far as assignments go, this is going to be an assignment for you, right? One of a very common mistake that happens on this assignment, you draw it perfect. You create the layers perfectly. You forget to scale it up, right? Or the other second most common thing, you scale it up and you don't think you've scaled it up because it doesn't look any different on the screen, and you scale it up again. And then you think, did that work? And you scaled up for a third time, right? So sometimes I get assignments where I know that the thought was there. I know that you knew how to draw it, how to put the layers, how to print it, but you struggled with the scale and it was 4 times the size it needed to be, right? Because you thought, oh, I don't know, I scaled it. I can't visually see that I scaled it, okay? And it is tricky. One little piece of advice that you could do to make sure that you recognize if you'd scaled something correctly, okay, is you can type or you can draw a line. So sometimes I will just draw like a little piece of line that I know the length of, maybe like, we'll just type in 10, enter, okay? And it's tiny. So I can type distance and I can measure it and it says 10. Now, if I scale up this site plan, and I select this at the same time, that line will scale as well. So if I measure it and it's larger than 10, I know I've scaled my object, okay? So we're gonna use the scale command. It's actually really simple. Here's the scale command. Okay, click. I select all the objects I want to scale. Okay, hit enter. My base point, I'm just going to choose my point of beginning for my base point, but I could have chosen the middle. I could have chosen over here. It doesn't really matter. But for this one, it makes sense to choose point of beginning to scale it. Click. You see how it can go smaller. It can go a lot larger, right? The scale factor I need to scale it by is 12. So I may need to make it 12 times larger. So I type 12, enter, and it scaled it by a factor of 12. Zoom extents. So you can see how on the screen you look at it and you think, it looks the same. Did it work? You know, well, there's a couple things I can do to verify that. I can zoom in here and type DIST, and I can measure this. Well, it's 120 now. So it's not 10, it's 120. That's 12 times larger. So I know that it's been scaled, okay? The other thing I can do is I can list F2, and I can see if it actually functioned. So I can look here and say, scale, select objects, base point. I didn't get an error that said cancel, right? This is after the operation happened. So I do know that by looking at my list that it did in fact work, okay? All right. This is quite the process, right? I always go into the site plan lecture thinking, oh, site plan's not too bad. And then I forget all of the stuff that I like to go over within them, right? Okay. Any questions on this? All right. A few more things. So I've just scaled my site plan. I'm going to delete my little measuring stick over there for now. Okay. Everything is looking really good. Now, some more settings we have to worry about. What I just did, taking my decimal, my site plan that I created in decimal format and scaling it up by a factor of 12, essentially I have taken it from engineering units to architectural, right? Ooh, bless you. So I no longer need to draw in decimal units because I am in architectural units at this point, okay? So something that, again, is something forgotten by a lot of students is I'm going to come down here to decimal and change it to architectural now. Okay, you see that? Don't forget to do that, okay? And I say that because if you were to draw a house or a design or anything else on this land at this point, it wouldn't be correct, essentially, okay? So there's one setting you have to think about. The second setting I want to bring your attention to has to do with the lines, all right? You see how now it's like these lines are, they almost look solid from far away, right? And we do know that these lines, they do need to appear dashed because the line type, that dashed line type, indicates something in drawings, right? It indicates that's a property boundary. The border line does. This inner boundary, right, that indicates that it's a dashed line. It's a dashed line and indicates it's an easement line, okay? So we want to make sure that when we print these that they do look dashed, all right? Now the reason that they don't look dashed right now is because the object is so large that the lines are kind of bleeding together, right? The scale of the object is so big that those lines look like they are continuous, okay? There is something we can set in AutoCAD to manage that, and it's called LT scale, line type scale. And it's a setting in AutoCAD that just sort of visually makes it so that those lines appear as if there are larger spaces between the dashes than there really are, okay? Because AutoCAD recognizes that we have extremely large objects and we have extremely small objects, and that we will be using the same line types for those. But in a small object, the line types will look great, right? There will be an adequate enough amount of space between the dashes to make it look dashed, Okay. In larger objects, we understand that there might not be as much space or appears as if there's enough space to show those line types appropriately. Okay, so essentially we have LT scale we need to worry about as well. So there's a lot of settings within site plans. LT, SCALE, LT scale, line type scale. Enter. The line type scale is going to be half your scale factor. Okay, we don't, and you're saying, well, what is my scale factor? I don't quite know yet, right? Okay, I'm going to show you where you find that. Okay. All right, just a couple final things. Your scale factor, I'm going to type Control P right now. I'm going to pretend as if I'm printing this drawing. Okay, and I want to remind you of something else. Let me just open it up here. I'm going to go to, I think I have work. Yes, okay. I'm going to go all the way to the end of this. You have this drawing posted on Canvas for you to use. And I'm going to remind you how to turn your pages so you can do it for your assignment. Organize. I'm going to read that one. There we go. Close. All right. I want you to remember something. So we have a scale row right here, and we have a scale factor row right here. All right. So if you look here and you say 1/2 inch, the scale factor is 24. Okay, what this essentially translates into is when I go to print something, if I choose the scale 1/2 of an inch is equal to a foot, okay, the scale factor that I'm printing at, 1/2 of an inch is equal to a foot, is 24. Okay, and that scale factor is tied to LT scale, line type scale. Okay, this drawing is going to be printed at, I think, probably 1/16 if I remember right. I think. So 192, what is 1/2 of 192? 192 divided by 2, 96. Okay, so if I print my drawing at 1/16 of an inch is equal to a foot, then my LT scale needs to be set at 96. So I'm going to type LTSCALE 96, enter. And do you see how immediately now my lines are more readable? They look like they should. Okay. Let me undo that. They look like that before. LTSCALE 96, enter. Okay. LT scale is kind of a tricky little beast. Most of the time it works. Sometimes it doesn't. Sometimes you follow the rules exactly as you should and nothing happens. And you're like, wait a minute, it's half the plot scale factor. I type that in, I hit enter, it looks good. I can't tell you why sometimes it works and sometimes it doesn't. There's just so many things going in AutoCAD. But my best practices for LT scale, if you're not getting dashed lines, start with half the scale factor and work in half increments down until it looks right. Let me just say that. This is really a visual setting. So if you change it to 48, nothing is really going to happen with your interface. You're not going to mess anything up. It's just going to visually change how the objects on the screen look, okay? And as long as you get them looking, we'll say, the way they should, then I don't really care what it's set at, okay? But I will give you kind of the general parameters to start with. Okay, so LT scale, enter. If I typed in 48, enter. See what happened? Not right. LT scale 24, not right. LT scale, let's do 192, which was the full scale factor. Lots of dashes between, or lots of space between the dashes, right? Let's emphasize this and do 250. Even more, let's do 500. Right? Even more space between it. That's again verging on not looking correct. LT scale 96, enter, and that's really kind of how it should be looking. Okay, and if you're questioning how it really should be looking, a good way to know that is to go back to our line type right here, click on border, and really it should look like this. You see that? And that is really what that looks like. Hidden should look like this. And that's really what it looks like. Okay? I say all these things very easily, like, oh, remember these 800 settings in AutoCAD, right? And I only remember them because I've been doing this for such a long time. So I'll continue to remind you about these things as we continue drafting and learning different things in this course. But there are a lot of settings, right? You open a drawing, you create your layers, you draw your layers, you're in decimal units, but you have to set your units to surveyor units for that to function, right? You create your drawing, you have to scale it, then you have to change your units to architectural, and then you have to print it, which means, you know, changing a setting of LT scale. There's a lot of things to remember in this one little site plan, okay? Final step here is printing this. And when I say print, again, I want you to create a PDF. I don't need a physical piece of paper. You're going to be submitting a PDF, okay? So Control P. This needs to be on, let's do an 11 by 17. That's what your assignment says. So Adobe PDF. If you don't have Adobe at home, you should, because it's free. You just log in. If you're printing from home and you don't have Adobe yet, you log in with your username here at the college. So your Bruin Mail login, right? So mine is sbrady14 at bruinmail.slcc.edu. You use your My Page password to log in with Adobe, and it's free. Okay. So I'm going to choose Adobe. I'm going to choose 11 by 17. Okay. I look at this drawing and it seems like it would be better oriented portrait, not landscape, because it's a long type drawing. Window. Whoop. Window. Looks pretty good. Center the plot. You see it's not centered, so I center the plot. I uncheck fit to paper. I'm going to choose portrait first just to make sure that it looks the way it should when I choose my scale. I'm going to choose my scale. Let's try 1/16 first. 1/16 is still too big. We need to go to 1/32, it looks like. That looks pretty good. Okay. Final thing, make sure it's portrait. Final thing, use your pens. If you don't use your pens to print, LaserJet CTB, that's a pen file. Okay, I use a lot of terms for a CTB file. You'll hear use your pen file, use your line weight file, use the CTB file, use LaserJet, right? All those things mean the same thing. I click on LaserJet, yes. I'm going to preview this. Looks pretty good, right? Looks pretty good. Escape, and I hit OK. Now, one thing that I did do, I could hit OK and I could create my PDF, which we'll do. Okay, we'll call this one Site Plan 1. Right, looks wonderful the way it should. If it's not oriented the way it should, then go to Organize over here and, you know, turn it the way it needs to be before you submit it, of course. Looks pretty good. One thing that you may or may not have picked up on is that, you know, I had set my LT scale to be appropriate for a 1/16 of an inch, and then I scaled it actually double that at 1/32. Okay, so if I look at my scale factor chart here, I don't have a 32nd of an inch, right? But I do know that 1/16 is half a 32nd. So this would actually be the appropriate LT scale, 192, for this drawing. And it's as easy as typing that in and hitting enter. I'm not, with this, I always would question this, I'm not scaling a scale that has already been scaled, right, and making it off. Every time I type in a new LT scale, it creates that setting according to like a 0 point, right? It's fresh every time. So that looks a little bit more appropriate. I could reprint this, Control P, and Adobe PDF, 11 by 17, window, right? Center the plot, uncheck fit to paper. We want this portrait. We'll do 1/32. We know that works. Make sure my laser jets are there. Preview. If it's not centered, if it's color, you know you've done something wrong, right? Go back and make sure your settings are correct. Escape, hit OK, and then we'll save it again. site plan 1, save, yes, I've got it open, so there we go. Perfect, 100% assignment, yes.
So anytime I try to preview or hit OK, it says the annotation scale is not equal to the plot scale. Do you want to continue?
Okay, if you get that error that says annotation scale is not equal to the plot scale, just hit continue and don't show me this again. Yep, and just keep going. Or if it says something like something about a batch plot, just hit continue to print one sheet and hit OK. You'll probably get that at home if you haven't done it before. All right. Any questions about any of this? You know, I think we'll stop here. But next time, so on Monday, we have 2 more complicated site plans that we're going to deal with. The assignment is up, so if you, or it will be, I'm going to hit publish in a couple hours. So there's this assignment that you have to do, and then you will have 2 more advanced site plans that you're going to have to draw. And what I mean by advanced is that they will have curves in them, okay? So your second assignment will be to draw this advanced site plan, and it looks like there's 2 of them. There's this one, and there is this one. So we'll go over these 2 on Monday, and I think we'll also try and go over trim and extend so that you know how to clean up some of the lines on your site plans. Okay, don't worry about if you want to complete the assignment for essentially the one we did in class as your assignment. But don't worry about, on that class assignment, don't worry about any of the text, okay? We haven't gotten there yet. So don't put any text on there, don't put any dimensions, don't do any of that kind of stuff. Just make sure you get the lines drawn. And again, I look for, you know, making sure that it's the right size, that it's been scaled correctly, the layers are correct, that it's printed black and white. Those are kind of the 3 main things I'm going to be looking for in this one, okay? Any final questions? Okay.